Hello students, how are you? Welcome back to my YouTube channel Physics Insight. Today in this experiment we will draw forward and reverse bias characteristics of a PN junction diode. This is the assembly having diode, voltmeter, ammeter and DC supply which we are going to use in order to perform the experiment. Now our first step is to evaluate the least count of voltmeter and ammeter here. Here two knobs are there in front of you to decide the scale of ammeter and voltmeter. If we put the knob at 3 volt, the upper 3 volt scale of voltmeter is used. If down, then the lower one is used. Now same is the case with ammeter knob. Since we know in forward bias PN junction device offers small resistance, then for the small voltage large current can be obtained. Then we choose during forward bias the small scale of voltmeter and large scale of ammeter, that is 3 volt on voltmeter, and out of microamperes and milliampere scale will be used on ammeter. Let's evaluate the least count of devices for the chosen scales. Proceeding for the voltmeter first. The 10 divisions on the 3 volt scale is equals to 0.5 volts. So the 1 division on the 3 volt scale will be equal to 0.5 divided by 10 is equals to 0.05 volt. So the least count of voltmeter came out to be 0.05 volt. Now analyze ammeter carefully. We are taking again the upper scale, that is the milliampere scale for this, and you can clearly see that there are 10 divisions between 0 and 2 milliamperes. Now 10 units of milliampere scale are equal to 2 milliamperes, and 1 unit on milliampere scale is equals to 2 by 10, that is 0.2 milliampere. So the least count of ammeter came out to be 0.2 milliamperes. Setting the knobs as per chosen scales: voltmeter knob on 3 volt and ammeter knob on 10 milliamperes. Before setting up the devices, do subscribe our channel. We will follow this circuit diagram in order to establish connections. Following the circuit diagram, we are connecting the devices. Here, black terminal indicates the negative terminal of device and red one indicates the positive terminal of device. So accordingly, we are setting up all the devices as per the diagram. As now we are done with the connections, let's test our device whether it is working or not. Switch it on and start operating it from rheostat. If both the ammeter and voltmeter start giving readings, that means we have done a really good work for establishing the connections. Now start taking the readings by moving rheostat provided on the left. Initially you can see both voltmeter and ammeter needles point at the 0th division. Note it down. Again disturb the rheostat and take the next reading. Voltmeter needle points at the 5th division and ammeter needle points at the 1st division. Let's record this reading. Repeat this step for taking more readings. Following the same way, we have obtained these readings. Using this observation table, now we will plot the VI characteristics for the forward bias, and we have obtained this graph which is indicating the forward bias characteristics of a PN junction. Now proceeding to the reverse bias characteristics. In reverse bias condition, PN junction offers higher resistance, thus gives less current for the large value of applied voltage. Hence we use 30 volt scale of voltmeter and now evaluate its least count. You can clearly see 10 units of 30 volt scale is equals to 5 volt. So one small unit is equals to 5 by 10, that is equals to 0.5 volt. Hence least count of voltmeter came out to be 0.5 volt. Now evaluating least count for the ammeter for microampere scale. Now 10 units on ammeter scale is equals to 20 microamperes. 1 unit is equals to 20 by 10, that is 2 microamperes. So the least count of ammeter in case of reverse bias came out to be 2 microamperes. Now setting the knob of voltmeter to 30 volt and knob of ammeter to 100 microamperes. For establishing the reverse bias circuit, we will use the highlighted components. Now we will connect the circuit as per the given circuit diagram. Now start making the connections. As now we are done with the connections, let's test our device whether it is working or not. Switch it on and start operating it from the rheostat. If both ammeter and voltmeter start giving readings, that means we have done a really good work for establishing the connections. Now you can see initially both the needles of voltmeter and ammeter are pointing at the 0th division. Note it down. Now for more next readings, move rheostat slightly. Voltmeter and ammeter show deflection. Note down the position of voltmeter and ammeter needles. Voltmeter needle is pointing at the 5th division and ammeter needle is pointing at the 2nd division. For the next reading, voltmeter needle points at the 10th division and ammeter needle points at the 2nd division. Like this, following the same procedure, we have obtained the following readings. Using this data given in the table, we will draw the reverse bias characteristics of a PN junction. So this is the graph which we have obtained by plotting these points, and this VI plot is known as the reverse bias characteristics of a PN junction. I hope this practical is clear to you all. So see you again in the next video. For more videos, stay tuned, do subscribe our channel and press the bell icon for notifications. God bless you all.